And so want to welcome as well Andreas Grabner, who has 20 years experience as a software developer, tester, and architect, and is an advocate for high-performing cloud scale applications. And tonight he's presenting a guide to event-driven SRE-inspired DevOps, the end of your monolithic release process.
Thank you so much. Thanks for giving me the stage here. Yeah, I know it's a mouthful of buzzwords that I put into the title. But I think just as the previous speaker, maybe I learned a thing or twice from borrowing from either marketing or sales. Hopefully you don't get thrown away by this marketing, what do they call it, bullshit bingo sometimes. No, seriously, this is really a problem that we want to solve here is we want to get rid of old ways of delivering software on new modern cloud native platforms. So just a quick couple of words to myself. My name is Andy Grabner. So Andreas is the full name, but feel free to call me Andy. On the one side, I work for Dynatrace for the last 12 years. Dynatrace, just as was presented earlier in the previous talk, is a software intelligence company, as we call ourselves, similar to what was presented earlier with Datadog. So in that area, I call myself a DevOps activist. We've been doing a lot of internal changes within the last 12 years that I've been with the company in the way we develop and deploy software. And I'm trying to also spread the word outside on what we've learned and also what we see with customers. But today I'm not going to talk about Dynatrace because today I'm going to talk about my second role, which is a DevRel role for an open source project, Captain. So Captain is a CNCF, a Cloud Native Computing Foundation sandbox project. And you can see all the different links here, whether you've, Twitter and so on, also Slack. If you are interested more about what we're doing, it would be great to follow up later on. So, but now to my talk. I think that when you're talking about cloud native, kind of the promise is, or let's say the ask of to delivery engineers or to anybody that runs modern platforms is that you need to do progressive delivery and you need to automate your operations workflow, and it needs to be looking like this. If you are a developer and you run your stuff maybe on Kubernetes, right? Then you want to deploy your new service. So let's say service 3 is deployed in dev, staging, and prod, and you have a new version, you do a pull request, and then what your pipelines should do, your progressive delivery pipeline, is deploy it in dev, run tests, then look at monitoring, similar to what we saw from the previous speaker, look at probes, look at monitoring data, evaluate SLOS, so service level objectives. I will talk about this more later, and then figure out, is this a good build, yes or no, and depending on that, for instance, automatically promote it into the next phase. In my case, staging. So the pipeline should automatically deploy it. Again, run tests, probably better tests, more tests, some load testing, some performance testing. And then again, after these tests run, you want to evaluate your key SLOs again. And based on that, now you have an option where you say, well, I may not feel comfortable to automatically deploy into production based on, I don't know, requirements that your company has. So you may have the option in your pipeline to say yes or no based on the data. But you make a decision based on some result that was already provided to you. Let's say it would be a good build. And obviously, if you then go into production, if you are familiar with all these progressive delivery options, let's say your pipeline supports blue-green, you do a blue-green deployment. Then after the deployment, you again want to evaluate, because just everything went fine in staging doesn't mean it's good in production. So in this case, like you see here, the evaluation of actual data from production says it's actually not that good. So that means your pipeline should automatically toggle back between blue and green and go back to the previous version. So, and then obviously reevaluate, because just toggling blue and green, I mean, technically it should all be back to good, but you still want to evaluate. And I think this is the reason why we want to do this as an industry, is because we want to increase speed and quality through automation. Now, the other thing is, it's not enough to just push something in prod, but it's important to keep it there in a safe way and in a healthy way. So on the production side, if later, after days or weeks after deployment, a problem happens, hopefully you have a tool that monitors, that alerts. And then what you want to automate is as much as possible when it comes to auto remediation. So you want to have a system that can execute an action based on a problem, let's say scaling up, but then also in the fashion of always reevaluate what has just been done to make sure that this action actually had the desired impact, bringing the system back to a healthy state based on your SLOs. And if that didn't work, execute maybe another action like a rollback, and then making sure that everything is back good. And I think this is what the industry talks about, to automate operations, self-healing, whatever term you give it. So I think this is the happy world, the hello world scenario that we all want to get to. And I'm pretty sure some of you on the call today are already there, but I also feel that in the reality, and at least that's what we have seen, most people are not there. Right, and this is just a stat that we use from our survey that we did last year, and also with engagements with our users of our open source project. We see that only about 5% of the people out there in the world are truly embracing progressive delivery and automate operations. And the question is why that is. Well, there's 3 big problems. I'm sure there's more reasons, but there's 3 problems I want to talk about today, and these are problems that Captain also addresses. The first thing is we're using, let's say, traditional pipelines for deploying cloud native applications, and we see a lot of time being wasted. We also see there's a lot of manual tasks along the delivery pipeline, especially around testing and especially around validation of the tests. And there's also a lot of time spent and wasted in remediation. And these are 3 things I want to show you now how we address with the open source project Captain, because we want to get, enable more people to actually do better delivery in the way the industry wants us to do it. So first problem, I think I don't need to reiterate, but a lot of time is wasted in maintaining monolithic pipelines. What do I mean with this? This is a screenshot of a rather simple Jenkins pipeline that we have had internally within our organization. It's only 350 plus lines long. I'm sure you have pipelines in your organizations that are much longer and more complex, but regardless how long it is, the problem with these traditional pipelines is that we have mixed information about what is the process, what are the individual steps that should be executed, where do we deploy to, in which environments, and also which tools are used for an individual job. So that means in this file, you have all the things in there that should normally be separated, because you should separate process from tooling, and you want to enable then in the end the developer to just run their pipelines. And this is not the only problem. At least, when we started with continuous delivery years and years ago, we started with a modern pipeline back then. And then we said, this is great. This works for me. It was kind of simple. But then we took this from one project to other projects, and then we slightly modified each version, each copy pasted version. And in the end, we ended up with, many pipelines that were all slightly different. And then this also led to the problem that we spent so much time in trying to figure out why pipelines don't work anymore. Like who created that pipeline? Why is this plugin used? Why is this particular code in there? What does this config file do? And so on and so forth. And this is just very challenging. So the solution, and I think what one of the big problems we want to solve here is we want to apply a new event-driven delivery model to delivery. Because the old way is kind of like this monolithic big blob that we've specified in our, let's say, Jenkins files or other files. So the solution and the way we looked at it is we want to remove these hard dependencies. So instead of having a pipeline file that executes all these individual steps by calling these tools directly from your pipeline definition, we want to break this apart. So we kind of want to separate on the one side, on the left side, the process, and we want to separate the tooling. And just as in modern software architectures, where we do the same thing, we use eventing to connect the 2 things together. So we have one component that is executing the process or maintaining or orchestrating the process, and then we have tools that can do certain tasks, and these tasks are then triggered by events. For instance, I have a new artifact. I can send an event and say, I have container number 1. I need to do a blue-green deployment in dev. Who can do it? And then the tool can say, I can do this. It does it, and then sends back the result once it's done, and then the workflow engine can continue its process. Rather simple, actually. The most important thing, though, is the separation between process definition and tool definition. And this now brings me to Captain. So Captain is an open source project. You can get to captain.sh, or you go to GitHub and find all the information. Captain runs on Kubernetes. So that means you can take any Kubernetes distribution, install it. It comes with a control plane. This is basically the whole logic that is executing all the workflows for both continuous delivery and also operations. And we use an eventing layer. Here, in the beginning, we used Knative, and then we switched over to Nets because in our case, Knative was just not the right fit and it was too heavyweight for what we wanted. It also has a UI and also an API. Now, the most important thing is the separation of concerns. If you want to use Captain for delivery, you define the process. In our way, we define the process in a so-called shipyard file, where you can see on the right here, I have a dev, staging, and prod environment or stage, and then I can specify what type of deployment, direct, blue, green, or canary should happen in which stage, what type of testing you want to do, and also what type of SLIs and SLOs you want to use for validation. And this is a file that can be specified by, let's say, site reliability engineers who owns the process. Then we have the tooling. We call the tooling definition, or we do this in a so-called uniform. So the uniform is the Captain uniform. It wears the tool belt. So here you basically say, okay, I want to use a Helm for deployment. I want to use JMeter for testing. I want to use Slack for notifications. I want to use Prometheus for monitoring. And then you just define this in that particular file. It's a complete separation of concerns. The great thing about this is one team can change the process, for instance, adding a new stage or changing the deployment model or changing the type of testing that should be done in case they have to, without impacting the tooling on the bottom. And on the other side, the tooling team can decide, you know what, Prometheus was good for us, but now we're moving to another monitoring tool like Dynatrace, or we used to use JMeter and now we're going to another tool that can do a better job. And there's no need anymore to rip and replace and kind of copy paste things all over in different pipelines where this is hard coded. So now having this, the beneficiary of all of this is in the end, the engineer, the developer, because what happens if you trigger a Captain workflow, the developer says, I have a new artifact, and then Captain is orchestrating the workflow by sending an event to beginning with config change. So everything we do will first get version controlled. So if I say I'm going to a new version, it gets changed in the Helm charts. If I'm using Helm, gets stored in Git. Then the next thing is the deployment will be triggered through a deployment event. When the deployment is done, the deployment tool sends a finished event, which then triggers tests. And when the tests are done, then an evaluation is triggered, where we have a component that is called the Lighthouse service that is then pulling out metrics from your monitoring tools and then evaluating how you're doing, and so on and so forth. And this process is true for both delivery, but also for automated operations. So the same process also works if you get an alert in production and you have a problem, then Captain can execute a workflow that says, what's the problem? Let's execute an action. Let's evaluate. If it doesn't solve the problem, let's execute another action. So this is kind of in high level what we've built. Now let me actually get to my first demo. The stuff that I've shown you earlier, this is the happy world scenario, is actually the demo that I have. So I have a 3-stage pipeline. I have an app with me. I have 4 versions of the app, 1, 2, 3, 4. They are different in not only background colors of the front end, but also they have some built-in problems. But basically, what I have done prior to the call, I have already initiated build number 4 to be deployed. And then what actually happens, and this is what we're going to look at, is Captain is first making the Git changes, is then, in my case, I'm using a Helm integration to do a Helm deployment, then JMeter tests are executed, and then a quality gate is enforced. And based on that, it's either automatically approved into the next stage, because that's what I specified. I said you can automatically approve in staging. Then the same process runs with a quality gate in the end. And if this is good, then I specified manual approval, because I don't want to let everything in production without an approval. And then you get the option to say yes or no, and then it goes into production. I decided blue-green there, and then quality gate is again enforced and said, hey, is this really good? If yes, we keep it, otherwise we roll it back. All right, so this is let me do my first demo quickly. First, I want to show you that what I've created. So this, the shipyard file, this is really my complete definition, right? So this is my definition of my process. I have dev, I have staging, I have prod, and you specify what type of deployment strategy you want, test strategy, and approval strategy. And in production, we also have a remediation strategy for automating production problem remediation. So initially, what you do is you basically say, Captain, we'll create a project. And let me have a quick look at Captain. So here's my Captain project. I have dev, staging, and prod. And as you can see here, build number 4 is in dev, 4 is in staging, and it's now waiting actually in prod to be promoted. So, but this, the YAML file kind of reflects itself like this in the UI. And what I can do if I want to kick off a new build, and again, just to save time, I did this earlier, but in order to kick it off, you can say Captain send event new artifact. So Captain is organized in projects. A project can have one or multiple services. For in obviously a microservice architecture, you would have multiple services on a project. And then you, in this case, I can specify what type of image I have. And this is my version number 4. So I executed this just before the meetup started. This is why what I want to show you is actually what happened with this request. Now on the service screen here, this is what we call this the Captain's bridge. On the service screen, for every service that I have in my project, I only have my simple node. I see when at 16:05, I kicked off that process. And if I go all the way to the top, on the right side, I see kind of my flow of events. So remember what I said, the first thing is the configuration change. So it actually makes a config change in the internal Git repository to update that version to version number 4. Then a deployment will be done. I also get the link to see, this is actually my infamous app, right? Build number 4 is in dev. It's not that exciting. It's a Node.js app running on Kubernetes. Then some tests are executed. So that means Captain triggers an event. I use JMeter that picks it up and then executes the tests. The test files itself are also maintained in that same Git repo that Captain uses to maintain all the other supporting files. Then an evaluation happens. In this case, I even didn't bother about SLIs and SLOs. I just said, in case the test is good, then go on. Then it was promoted into staging automatically. Configuration change happened. Then it was deployed. So in this case, let me open this up again. Build number 4 is in staging. That's great. And then tests were executed, a little heavier tests. I call them performance peak tests. And then SLIs were retrieved. So this is the thing now where everything we do, we allow you to specify SLIs and SLOs. So in this case, my system was pulling in metrics from my monitoring tool. And if you look at the last column here, this is the latest build. I can see every metric that I pulled in is passing the objective, which means in the end, I got 100 points. I get to more of this in my next section, but this is the reason why it was then considered as good. And now it's waiting in production. So now it says, hey, I have a new build. Currently, you have build 3 deployed. Build 4 is waiting. It achieved 100 points, which is great. Do you want to approve it? And I can either approve it here. I can also approve it here because I also see here build 4 is in dev, 4 is in staging. In production right now, let's double check this. In production, I still have build number 3. That's the strange yellow background color. But I can now say, you know what? I think this is really awesome. It's 100 points, all good. Let's go and put it into production, which means now the workflow keeps going. And if I go back to my services where I see kind of the workflow, I should see now in prod, the approval was triggered, and now the configuration change is made, and then it's going to be deployed. Okay. And then again, once this is deployed, it waits a little time, looks at real user data, and then decides, is this good or is it no good? Exactly. So this is kind of a quick overview of how event-driven continuous delivery works, where I specify the process in one file and where I have Captain sending events to different tools that are then doing the actual job. So Captain is really the orchestrator or the choreographer of this process. All right. And let's see if build number 4 has made it into prod already. It typically doesn't take too long before I go into my next. It probably takes a minute or two, and then that's just a Helm update. Let's say build number 3 is in prod. If I hit F5, it should soon be build number 4. Yeah. I will cover this. Yeah, it takes about a minute or two. All right. So this is the first the first use case, event-driven continuous delivery. The second, actually custom example too, or user example. Patrick from Amazon, they are using GitLab for CI, and then this is also to show that Captain can not only be triggered through the UI, but we have full automation That means they are triggering CD, so continuous delivery use case from Git once GitLab is building the containers, pushing it to the registry, then they make a REST call to Captain, and then Captain takes over and does all the quality gates, the automated testing, and so on. So this was the first use case. Let me just double check now if build number 4 is now in prod, and let's open this up again. There we go. Right, this was now it's, so the way I specified it from a testing strategy, I said real user test strategy. That means it's now doing a blue-green deployment, and it's waiting for real traffic to come in. I have a little load generator in the backend that simulates real users, and then depending on how this is, it will either keep it or it will roll it back. And a little spoiler, it will roll it back, because build number 4, I actually built some issues in there, so it should automatically roll it back in a couple of minutes. So first use case. Second use case, and you have already seen this a little bit, is that a lot of organizations we've seen are spending a lot of time in manual deployment validation. So what that means, I know a lot of you have probably invested already in great CI/CD, where whatever tool you're using, you're building, you're deploying. I know a lot of you have also done some great work in automated tests. And then, however, a lot of the time, there's a lot of manual time wasted because of somebody needs to look at the functional test results. Hey, this test failed, but this is really business relevant. What is this feature? Which features actually tested? Does this violate my SLOs and SLAs? Well, I don't even know, because I never thought about SLAs maybe. Or if you have integrated load testing, then this is great, but there's so many metrics. So what is a good and a bad performance? Well, response time seems good, but CPU is now higher. Is this a problem for production because it will cost us more? Or if you're pulling in monitoring data, whether it's Prometheus or Dynatrace or Datadog, what we have heard earlier, there's just so much more data, and it seems a lot of people are just overwhelmed with then making a decision, is this good or no good? And this is also what we want to solve with Captain, and what we are solving with Captain. And you've seen a glimpse already. These are the SLI and SLO-based quality gates. It's a core capability of Captain that is used in the end-to-end delivery workflow I showed you earlier. But the good news is you can also use it standalone, which is kind of like your entry level in case you have existing pipelines and you want to elevate them. So how does this work? Just a little primer. I assume most of you are aware of Google's SRE practices, but in case this is the first time you hear it, Google talks a lot about SLIs, which essentially it's a metric, something that is measurable, like the error rate of login requests. Then you have SLOs. What are your objectives? So I'm expecting that my error rate in production in a 30-day period is less than 2%, because otherwise I really have a problem, because a lot of our users cannot log in. Think about online banking. If 2% of logins failed, then you have a lot of pissed customers probably. And then you have SLAs, service level agreements, which is very close to SLOs, but this is typically where you have a business agreement, a binding target, maybe even contractual obligations with your end users. Right? And this is typically where you say, hey, we have to be fast and reliable 99% of the time within a 30-day window. If this is really the first time, there's a lot of great content out there from Google, a great video, but essentially SLIs drive SLOs, which inform SLAs. And this concept is typically used in production, which is great. But we thought, well, it's great that you use it in production. So we have monitoring tools out there where you can specify these SLO rules, and then they will evaluate this for every service, for every app at all the time. And then they're great for reporting and alerting and all that. But what we thought, if people finally start looking at defining SLOs in production, meaning they actually sit down and think about what is the success criteria of my service or application, why only do it in production? Why not also shift it left? Why not also use the same concept, a metric against the threshold over a certain period of time? Why don't we use this in continuous delivery? And that's what we do with Captain. So with Captain, every time you push a new artifact through and you run tests, we look at these metrics, we validate against them a threshold, and we look at the time period of the tests that you ran. And the point here is you immediately get feedback on, hey, response time is now 10% slower, or memory consumption is 50% higher than before, or we make 50% more database calls than before with login. This is really something we want. or do we want to find out about it in production, or can we stop it early? And this is the whole idea of shifting left this idea. Now, the way Captain works from a build-to-build perspective, just to give you a little overview. So you specify your SLIs. So that means you specify what metrics are important. You specify SLOs. We've implemented in a way that you can either specify fixed absolute values. So that means something like it has to be faster than 100 milliseconds, or you can also do relative values. Relative means it should not be slower than 10% more from the previous build. So it's for regression detection, because we can compare against previous baselines. So you specify your SLOs and you specify an overall score. So we always look at all the metrics, and then we score all the metrics between 0 and 100. And then you can say a good build has to have at least 90%. So how does this then play out? If you are saying, Captain, I want you to evaluate this particular service for this particular time frame, then Captain, you have also given Captain your SLIs and SLOs. And then basically what Captain does, it automates pulling out the metrics, comparing them for you, and then calculating a score. And this does it for every build, right? So here's just some example. If things get slower, 75% is still good in build 2. Build 3 comes along. Response time and failure rate is good again, but then they made the developers built in a regression. Now for login, we have, instead of 1 database calls, we make 2 database calls, but our SLO was that we should not increase the number of database calls. And this is probably an architectural regression, so we can stop it there. And then the idea is, hey, they get this feedback so fast. This is cool. That means we can fix this right away before it goes into prod. So this is kind of like how this works build to build. Technically, Captain is open source and it's event driven. So that means you can loop in any type of data source out of the box right now. Based on our current contributions, we support Dynatrace, Prometheus, Neoload. In the works right now is Wavefront. I think somebody's working on a Splunk integration. And I'm encouraging everyone to build their own so-called SLI provider. Technically, how it works, if you want to use this capability, you define so-called an SLI file. These are your indicators, typically the query language on how you can query a certain metric. So you give it a logical name and then the query that your integration can use. And then you specify your SLO file where you have your objectives and your pass and your warning criteria. And if you then say, Captain, please do the evaluation, then Captain reaches out to these individual tools, sends an event and say, hey, I need these metrics for you in that time frame. Then these tools return it. Captain does the validation, scoring, and then comes up with a total score. And based on that, then makes an automated decision. Or gives you back a result between 0 and 100. So one demo that I want to quickly show you, this is now my bias. I am working for Dynatrace, a monitoring company. So for Dynatrace, we made this a little easier for that integration. You just build a dashboard where you put metrics on, and then Captain is parsing that dashboard and using this for the quality gates. So what this means, the app that I've showed you earlier, by the way, it was just rejected. Can you see this? My production is back to build number 3. Really cool. Well, I guess build number 4 had a problem. Why? Because in production, it only scored 82% because it seems there was an issue with response time was much slower and failure rate increased. So there was clearly an issue. Now, how does this work? How does this evaluation work? Let me show you. If I go to my heat map again, behind the scenes, what we have is a dashboard that I've used where I put all the metrics on that I want Captain to analyze. So I built a dashboard that includes response time metrics from my pods, from my code. I also have metrics here from my testing tool because I'm using JMeter, and then JMeter executes a couple of individual test cases so I can see all these metrics. I also have things like CPU, memory, and also it's a Node.js based app. I included event loop tick count. So that's what I specified. So you put the metrics on. You can also specify your criteria here, as you can see. And then really what's happening is that when I say, Captain, evaluate my quality gate for that time frame, then it just automates what I would normally do manually, looking at dashboards. And this can be, these metrics, I think the speaker before has talked about Kubernetes metrics, right? I can include any type of metric that your monitoring tool can give you. Pod level, node level, anything that you say, these metrics with these thresholds are defining a successful operations or are defining a successful release. And then it will be used here or like as part of my delivery. But what you can also do is you can also kick it off through a tool like Jenkins. So I typically use Jenkins in my demos, and I believe now I actually need to go to the VPN. Sorry, quickly. I want to kick this off from here. So if I go to my Jenkins server, then I have a Captain Quality Gate. So in this case, I'm basically just, assuming the use case is you have an existing pipeline at Jenkins that deploys and you run your tests, and then you can just kick off a so-called Captain Quality Gate. So I can now, and this is just a sample pipeline that is just making a REST call to Captain, and what it gave it. And let me go back to this screen. I just wanted to kick it off. So you see Captain project, a stage, and service. And then I give it a time frame. I also specify what SLIs I should use. So my pipeline is telling Captain, hey, here are my SLIs. I'm pulling the SLIs from a YAML file and then giving it to Captain. And now when the test is done, it seems that I got, let me get to the overview here, build 77, unstable build. Well, that probably Captain returned, this is not a good build. So what I can do now is I can say Captain results in the bridge. So let's open this up. There's a direct link now to that particular evaluation. So you see here, I've run a couple of evaluations in the past. Build 77 from Jenkins has been evaluated, and here are all the metrics. And the reason why I was penalized is because the service transaction count wasn't good. And there's the dashboard that was used behind the scenes. Okay, I think it is a different dashboard that I use here, but you get the idea. You can put whatever metric you want. And this can come from Prometheus, this can come from any other tool. The concept is that you let somebody automate that process. Okay, good. So to get to the end, a couple more slides and one more use case, but I'm almost done, unless somebody has a question, because I can hear people talking, unless somebody has a question.
Actually, I think I'm just going to make sure some people are mute and making no sound, but we actually do have a question that came in from Leticia, is asking, does this promote/support SLO-based monitoring and alerting? As in, can I get alerts only when my error budget burn rate is approaching a predefined threshold? Can it help me reduce alert fatigue, helping me focus only on the issues that can impact my SLOs?
Yeah, I think, well, it's a very elaborate question. So thanks for that, Leticia. I think we're talking about two things here. On the one side, I've been talking about these SLO-based quality gates in delivery. So before you actually make it into production, right? So that means if a metric is kind of violated, then don't even push it out. I think what you are saying is, yes, in production, of course, you can use this in production to monitor or to look at how are my SLOs. So for instance, you have 5 days left in the month and your error budget is only 5 more minutes, then you can use this also to say, you know what, actually, I don't want to promote any new build in production because 5 more minutes is simply not enough. So I think this would also be a great extension to just call your monitoring tool and say, how much error budget is left? Do you actually want to evaluate? Do you actually want to allow this? So what you can actually do, you can take the error budget as an SLI and also make this a key SLI. So what you can do with Captain, you can define individual metrics as key, which means if this metric fails, the whole build is considered fail. And you can say, if error budget, I don't know, is lower than 5%, then always fail that build or not allow anybody to deploy into production. I hope, Leticia, this kind of answers the question. Coming just forward, yeah, I showed you the Jenkins example. One of our users, they are also using GitLab pipelines for building for testing, and then in the verify stage, they now are using Captain. So just, instead of having somebody manually sit there or building something yourself, they just run Captain, and then Captain is pulling the data from their monitoring tool. And this saves them a lot of time. Third problem, and this is a rather quick one, because I want to make sure we have enough time for questions. So this is the whole troubleshooting problem in production. So we want to solve this, obviously, again, through an SRE-driven approach. What does this mean? Captain also has the same process that I showed you for delivery for operations, for operation processes, which means if you get an alert in, let's say you get a Prometheus alert, or you get a Dynatrace alert, or a Datadog alert, or a New Relic, whoever alerts can send this information to Captain. And then in Captain, similar to what you saw earlier from me with my delivery pipeline definition, with my dev, staging, and prod, and the different actions, Captain defines the remediation process or workflow through a so-called remediation file, like you can see here. That means it maps to a problem, and then it specifies actions. Actions are, again, things that Captain triggers an event, and then you need an action provider that can actually execute that action. So in this case, conversion rate dropped because of CPU pressure. Then the first action could be, scaling up. So Captain would then trigger the execution, but then also, very importantly, not just fire and forget, but reevaluates your SLOs. I also added BLOs here, business level objectives, because you can also include business metrics here, like conversion rate, user experience, and all that. And if this solves the problem, great. If not, then maybe execute the next action. If you know your conversion rates are dropping and scaling up didn't help, and you have a campaign running, maybe stop that campaign by making an API call to Google and say, stop that campaign right now, we need to first fix it. And then again, reevaluate. And if nothing of this works, then you can still escalate. So this is kind of the workflow. And what I've seen, and we've been presenting this, and everybody's yeah, this is great, but then when we say, well, it's implemented, then they say, no, in production, this is too risky. And so this is why we think Captain auto remediation in pre-prod or in a safe prod environment makes a lot of sense in combination with chaos engineering. So we're currently working with Litmus, who is also a CNCF project, also with Gremlin and some others, so that in a safe environment, in the pre-prod environment, where you, let's say, run some load and then you enforce chaos, you want to use this to actually, first of all, figure out, does your monitoring even work? Does your monitoring pick up that chaos? In case the system, let's say Kubernetes are in built-in mechanisms that doesn't bring the system back to a healthy state. So the idea is, let's combine testing and chaos engineering to then define, battle test, and validate your auto remediation. Because in the end, your auto remediation is just code as well. And code, untested, should never make it into production. And so we give you here a way to test your auto remediation in a safe experimental environment, so you can validate that it works and it brings the system back to a healthy state. It's the same process as I had before. And if this works, then, if a problem like this happens in production, you have tested this workflow. And this is what we think, it could be a great idea for site reliability engineers to combine these things. So let's wrap it up on my end. So what is Captain? You can read for yourself, and you saw it, event-based control plane, and we focus on a couple of use cases. We're an open source project. All the events that we're sending are cloud events based on the standards. It's very easy to build your own extensions. You can run Captain wherever you want. You can also, obviously, wherever you want, on some type of Kubernetes. But the great thing is, through the event-driven model, Captain can not only do things within that Kubernetes cluster, it can also call other tools that sit outside. So we have users that are using Captain to orchestrate the delivery of a classic legacy application, because they can have Captain trigger a Jenkins pipeline for deploy, and then Captain executes tests, and then Captain does the evaluation. So it's not limited to just Kubernetes. That's what I wanted to say. Yeah, with that, we are addressing all of these problems, hopefully. And if you want to get started, there's a lot of tutorials out there on tutorials.captain.sh where you can get started. And now I want to open it up officially for Q&A.
Thank you very much, Andreas. Andy, it was a very interesting talk, very well prepared and very well given. Thank you very much.
Thank you.
There's a follow-up comment by Letitia, who says, yes, thanks. The error budget as a key SLI piece is quite an interesting way to get SREs and devs to collaborate. The practical implications are definitely challenging.
Yeah. Yeah, I know. I mean, practical implications. So I think what I've seen, and correct me, Sam and others that are out there, I think we're all very new to this whole cloud native world and talking about it, sitting down and figuring out non-functional requirements, NFRs, which I believe SLOs are. And I think a lot of people have not thought about all of this and how to include this in the delivery process. I know I don't want to generalize. I know there's people out there, because otherwise we wouldn't talk about it, because some people have done this. But yeah, it's definitely not something that you do over the weekend. That's what I say. Yeah. I think the second question from Jim: does Keptn work well in a multi-tenant Kubernetes cluster? How is authentication managed in Keptn? So right now, as of version 0.71, Keptn is installed on a Kubernetes cluster, and it's basically the control plane. The control plane, you install it on a Kubernetes cluster, and through the event-driven architecture, it can really call other services that can then do things anywhere, as I said earlier, like you can call the Jenkins pipeline. Now, the stuff that we bring with Keptn, some of the tool integrations, like we have a Helm service that is doing Helm deployments, right now is only supported on that same Kubernetes cluster. But there is works in the place where we are basically not ripping this apart, but making our services also work multi-cluster. This is on the roadmap. And the other thing, what we've also seen people do, you can have a Keptn on every Kubernetes cluster. And then let's say you have your pre-prod cluster and Keptn is doing its thing. And then it says, hey, this is now done. It's ready for be promoted into the next stage. But in that cluster, there is no more stage. However, Keptn sends out an event, and that event can be sent to the next Keptn in the next cluster. So that would be one option. But Jim, we are definitely we have this on our radar, and as we are an open source project, it would also be great to get contributions from people that actually know how to do this pretty well. So the more people that can contribute, the better to get these things faster.
Great questions. Thank you, everyone.